Jason Rzucidlo, reporting from the 2011 SAE World Congress, and I'm being joined by
Vincent Sabatini. I work for dSPACE Incorporated. I'm a technical support engineer there.
So first of all, tell me a little bit about this EcoCAR2 competition.
So the EcoCAR2 competition is a competition sponsored by the Department of Energy and General Motors. It challenges 16 universities from across the United States and Canada to re-engineer a stock vehicle to be more fuel efficient and to get better emissions while still retaining the performance and the utility that's expected in a consumer vehicle. So each of the 16 universities, we just announced which universities got in today, are going to be given the same vehicle platform, which is the Chevrolet Malibu. They're going to take that vehicle and re-engineer it by taking out the engine and putting a more fuel-efficient engine in, or putting fuel cell technology in, putting electric components in, like a high-voltage battery, lithium-ion battery packs, or electric motors to increase the fuel efficiency of the vehicle.
So now, is there going to be some sort of a prize at the end of the competition?
Yes, there is prizes for the universities. The single biggest thing that the different students get out of it is they get the real-world experience. They're working with industry partners and sponsors of the competition, like General Motors and like dSPACE and a bunch of other competition sponsors. And so many students get hired right out of the competition by General Motors. I was a member of the Embry-Riddle Aeronautical University. I got hired by dSPACE, and now I'm working as one of the sponsors. My friend from my team works for General Motors now, so that's the big thing. Yeah, there's prizes, but that's not the goal. It's the education that all the students in this get. I learned so much in this competition, and that's the single greatest part of it.
So go ahead, tell me what this is.
So this is a demonstration system of the type of technology that dSPACE is donating to all the teams involved. This is our mid-size simulator. What teams can do with this is they can rapidly prototype the controller for their vehicles. Especially hybrid vehicles, there's so many different controls and signals that have to go through the brains of the car, the vehicle, to safely and efficiently control the vehicle and all of its components. It's a very daunting task, and it takes a lot of time and a lot of effort. Our system helps teams do it much more rapidly, much more efficiently, as well as safely. They can test their vehicle controller without having an actual vehicle to test it on. We have a virtual vehicle in our simulator here, and we have a prototype controller that controls this virtual vehicle. So they can rapidly run through drive tests without any of the dangers of driving a prototype vehicle, without the cost of building a prototype vehicle, and much more rapidly than having to actually drive the vehicle. They can run through tests a lot faster with our system. And this is just kind of showing what the user would see, and you can see kind of like a simulation dashboard. So we have our vehicle driving right now. This is how fast the vehicle's going, but it's going all electrically. So you can see the power is coming from the battery to the electric motor here. So even though the vehicle's driving, there's no engine speed going on. And this is just a simple example of the type of controls that go into this vehicle.
Is there a few buttons you could push there, or what can you show me?
Driving through a set simulation. So this is a federal test procedure, so it's a standard driving procedure that the EPA and the Department of Transportation have developed and use. And this is, what the actual government tests vehicles on. They drive this same cycle. So this is what our virtual vehicle is driving as well.
Very cool. So tell me about the car that you worked on last year.
So the car that my team was responsible for EcoCAR1, the vehicle platform, was a Saturn Vue. And what my team did with it was we took out the engine that was in it and we put in a 1.3 liter biodiesel engine. So it ran on a efficient fuel. We had a 2-mode front-wheel drive electric motor in it, as well as the transmission. And then we had a A123 Systems lithium-ion battery pack in the rear. So we had a 25-mile electric range. I haven't been involved with the team the last year. It's a 3-year competition, and EcoCAR2 is also going to be a 3-year competition. So my previous team is finishing up now, and the finals for EcoCAR1 will be held in June in Milford Proving Grounds here in Michigan, and finalized in Washington, D.C.
So you helped to increase the fuel economy on that vehicle quite a bit?
Yes, like I said, I'm not sure exactly what their final standings are. I did a lot of the modeling and simulation the first year.
So what else can you tell us about this here today?
Just that we're really excited for the new competition to start. We have a local Detroit college, Wayne State's involved, so we're pretty excited to have them involved. I'm happy because Embry-Riddle, my alma mater, is also in the competition. But we're excited to work with all the teams, and I'm really looking forward to seeing what the teams come up with.
All right, thanks a lot. Nice meeting you today. Yep, thank you.